What's up, geometry students? We are going to work through the Unit 1 test. This is a test. Tests are worth 60% of your grade. If there's 6 tests total, each test is worth 10% of your grade. Your homeworks are worth only 10% of your grade. If we have 30 homeworks, maybe even more, then each homework is worth a third of a percent. So, like, getting this completed and turned in for a homework grade is worth so much less than actually studying and preparing ourselves. You have to turn in all 30 homeworks to be equivalent to one test grade, which is 10% of your grade. So when I do this, great. You can like see the answers, but make sure you guys know what you're doing. And if you need to redo it, do it yourself, do that. Okay? I'm going to kind of plow through the problems. M is the midpoint. Pay attention to words. AM is 4x plus 5. AB is 4x plus 100. How can we use that to our advantage? Since M is the midpoint, AM plus MB has to equal AB. Doubling, you can either cut this in half and say 2x plus 50 has to equal 4x plus 5, or you could say 8x plus 10 equals 4x plus 100. Solve. I'm going to divide by 2. I'm going to divide by 2. What is AB? AB is 4x plus 100. Well, I know 4x is 90, so 90 plus 100 is 190. Gotta open this back up. Cool. Next, CF has 2 points between C and F. So we got CF. CF has 2 points between CF such that CD equals DE equals EF. So the 2 points must be D and E, where CD, DE, EF that are all equal to each other. CE is 12. If CD, DE, EF are all the same, well, like this plus this has to equal 12. This doubled is 12. This must be 6. So CF must be 18. There's a lot of things you could do to make sure you understand what's going on with these angle hunts. You could extend things if you want to. Realize this picture is really the same as this picture down here, just like copied and pasted. 30 degrees would correspond with this 30-degree angle if you took a copy of this and pasted it down. Again, I'm like trying to make it clear. If you extended this line and extended this line, you'd be able to see this picture here and here. If this is 30 degrees, this is 30 degrees, this is 30 degrees, this is 30 degrees, X is 30 degrees. Y is going to be equal to 50 plus 30. I just know that right off the bat, but you could double check. If this is 30 and this is 50, this is 80, that means this is 100. And these two, Y plus 100 has to equal 180. Okay. If you extended this line and this line, you'd realize this is the same picture as this. That means X is 110. 40 plus 70 is 110. I actually know that Y has to be 70, but let's say you don't know that. You would know that this is 70, this is 40, this is 70, this is 70 as well. So they're both 70. This is 90, this is 50, this is 90. So this is 140, this must be 40. Okay, cool. if this is 90 and these are parallel, this has to be 90. So this y has to be 50 as well. 50 plus 40 is 90. So x is 40, y is 50. We see actually two triangles here that you're going to use to your advantage. This is the first triangle. This is 90 degrees. This is 60 degrees. 90 plus 60 is 150. This must be 30. Cool. Going in the other direction. You got this guy, that guy, that guy. And if this is 90 and this is 20, that's 110. These two must add up to equal 70. We already know y is 30, so x has to be 40. Cool. It's probably going to be the same thing here. We got two different triangles that we have to pay attention to. I think I could find y first. This is 90, this is 40, so that's 130. So this is 50, y is 50. If y is 50, we can then look at this triangle here, where x has to be 40. So this is 90, this is 50, that's 140, that has to be 40. Cool. Listen, these are just examples of some of the big quiz type problems. Just make sure you also do your big quiz review. Again, I would advise, I took some of the problems like directly similarly to your test and put them on the big quiz review. BT bisects. What does it mean to bisects? It cuts in half. ABT has to equal TBC. Solve. What are you trying to find? The value of x. I found the value of x. I subtracted 5x. I added 7. I divided by 7. Take your time solving. I'm doing this quickly. I'm doing this quickly because I already made a video and it didn't save. Technology sometimes. HJL is 13x plus 87. This plus this has to equal this. You can go ahead and do the addition right away if you want to, if you want to write it out. Just remember, like, same side combined, like 13x's plus 10x's. Make sure you say 23x's plus 47 has to equal 13x's plus 87. I get 10x's equal 40 after subtracting 13x's and subtracting 47. I get x equals 4. HJK is 13 times 4 plus 20. So I got 40 plus 12, which is 52, plus 20 is 72. Okay. All right. Guys, constructions aren't bad. If you can create an isosceles triangle from two side lengths, I'm literally starting with, like, what do we have? Question number 10. Question number, like, pre-construction is the following. Can you create an isosceles triangle using two side lengths that are the same and a side length that is different? Hopefully you're saying yes, because if you can create an isosceles triangle, you're good for pretty much all of your constructions. Okay, so let's do that. Let's create an isosceles triangle. Let's use C and A. All right, I'm going to start with C. I need to make sure I have like a line segment. So here's my isosceles with one C length and two A lengths. Here is my C length. Ba-bam. And now let's find my two A lengths. That's probably good, just to double check. Okay. Here is one A length coming from an endpoint of C. So this is my side length C. This is one endpoint of C over here. This is another endpoint of C over here. I'm going to be coming from C from there, and I will get this length as possible A's, and then I'm going to flip it, go to the other side, and here's the other length of A. Now, why do I show you this? Because like the isosceles triangle that I just created is used in almost every single construction you are asked to do. That isosceles triangle, and then having it flipped, meaning two isosceles triangles on top of each other, meaning you have your rhombus. And the rhombus, my friend, is Mr. Construction. The rhombus is Mr. Construction. If you create a rhombus, you win. Why do you win? Because of the following. You get 1, 2, 3, 4 sides are the same. You get two diagonals that cut each other in half and create 90-degree angles and cut the angles up top in half. You create so much just by doing that. Okay. And if you could do that, anything can be done. Cool. So, construct an equilateral triangle. All right, well, equilateral triangles are easy. So let's construct an equilateral triangle. Which length are we using? A, length A. Okay, so I'm going to construct an equilateral triangle. It's easier than an isosceles triangle because you never move your compass. You literally just say, this is the length that I will be repeating over and over and over again. So here is a length. I'm going to mark off length A. Here is length A. And now here are other possible places for A to go. Great. Flip. Here are other possible places for A to go. Here's the location where I would get my length A coming from this point, and I'd also get my length A coming from this point. Hooray. Put another equilateral triangle on the other side, and boom, you've created a rhombus. Boom, you've constructed everything you want to do. Okay, next, construct a copy of angle E. Yo, watch what I'm going to do. I'm going to create an equilateral triangle. And then after I create the equilateral, I mean, not an equilateral triangle, an isosceles triangle. After the isosceles triangle is created, I'm going to be able to create the angle again. Like you think this is different. This is not. Look, this is one new thing. I create an arc. The arc says this length and this length are the same. So I'm going to label this not as length A or B or C, but length E. This is length E, this is length E. And look at this point to this point. This is a different length. I'll call it length F. Could you create an isosceles triangle with one length F and two length E's? I hope you're saying, yes, I can, Mr. Messner. Here, let me start with a line segment. Let me figure out length F. Here is my one length F. Now, this might be different from like the instructions, but this is what I'm going to teach you. Here's my one length F. Now, could you do two length E's? Yes, I could do two length E's. Okay, let me figure out what length E is. Cool. Here is one length E coming from this point. Flip it. Here's another length E coming from this point. We have just copied down our angle. It's literally the same thing over and over and over again. Label it just so you know. This is E, this is E, this is F, E, E, F. Guess what? This angle is the same as that angle. Now, how do we do it like from our construction project? Well, we usually say, okay, start with this, and then let's measure off length E and start with the arc of E. And it's like, fine, you could do that. You could start with the arc of E. And literally, this is like just as easy. the key is to make sure you're matching the lengths of this isosceles triangle. Here's length E. We have one E. We don't know where the other one goes. Well, we could use length F. And it's like length F goes from there to there. There's length F. I'm going to flip it because I know 1 point. Here's length F. So here's E. Here's length F. And then here's like the other E. Here's E here. There's E here. There's F there. It's the same thing that I did there. Okay. Okay. But you don't realize it because like sometimes the instructions don't help you. 1/2 C minus A. Easy. Do you know how to create a rhombus? Then you should be good. Here's C. Why that's happening. Here's C. Start at this point. This is C. So that's length C right there. Label things, guys. Please label things. Where's A? Okay, here's A. I wish I could move this in 2 different directions. Here is A. Great, here's A. So I'm going to subtract A. There is A. From here to here is A. Here to here was C. C minus A must be this. I'm going to mark off that distance so I can bisect it a little bit nicer without all the stuff going off. So here is C minus A, and I'm going to measure it. So here's C minus A. I need to bisect it. Well, create a rhombus. 4 sides that are the same. What side length should you use? Whatever side length you want, okay? I literally could be as long as you want. You could literally use C minus A and create an equilateral triangle with C minus A. And as long as the 4 side lengths are the same of this quadrilateral, you will have the properties that you need to do. Here, boom, make sure you go below, above, and below. It's always safe, guys, to go above and below. So like when in doubt, just go above and below and you're doing the right thing. Like there's only one instance where you don't need to go above and below. Now, why do I do that? Because this length here is the same as this length here, is the same as this length here, is the same as this length here. Now, they happen to be all the same as this length, C minus A. But what's the key? And you're using straight lines to do this. You're using a straight edge to do this. I'm not, but you should be. That this diameter bisects it. So this length right here is 1/2 C minus A. All you're doing is creating a rhombus over and over and over and over again. E is 76 degrees. Construct an angle with 38 degrees. Easy. I'll create a rhombus. I'm going to go off of angle E just because it's there. How can I create a rhombus? So easy. Let's start by figuring out a length and just keep using that length. Boom. I know this length is the same as that length over there. Now I'm going to understand that this creates a diameter, and boom, there's your isosceles triangle. And now let's continue that length up here. It doesn't have to be the same length. Honestly, you can make a kite and it works. Let's just keep going and create that length over there. And since I didn't move my radius at all, I know that this length here and that length there, use a straight line to do that, is the same as this length here, as this length here. You've created a rhombus. A rhombus has a diameter that bisects the line segments, bisects the angles, It is Mr. Perpendicular. It is Mr. Bisector. This angle right here is 38 degrees, right there. I should blow it up. You want me to do that again? It's actually tough to do it again. It's so fast. It's so easy to do. It's just like, hey, should I create a rhombus? Yeah, you should. Okay, cool. Here, side length, same. Same side length. Same side length. Oops. Oops. Come on. Boom. This length is the same as this length and this length. Boom, boom. You create a rhombus. Rhombus has the beautiful properties of having perpendicularly bisected diameters. Connect this point with this point, and you not only bisect this angle, but you also bisect this line, and you create 90-degree angles there. It's like, that's what it is. It's beautiful. It's easy. Right isosceles triangle. Fine. Sure. Easy. You want a right isosceles triangle? I'll give you a right isosceles triangle. First, what do you want? The isosceles or you want the right? Well, the 90-degree angle is the important thing that is tough to come by. I'm going to create the 90-degree angle first. So how do I create a 90-degree angle? I perpendicularly bisect something. Here, what do you want to do? Do you want to use equilateral triangles? Do you want an isosceles triangle? It's up to you. Let's do an isosceles triangle. So I'm just going to go this length, but I'm going to use like this point and this point as my important points. But I'm just going to make sure I have this length the same in two different directions. I'm going to flip it. We're going to do the same thing over there. That way I have four of the same lengths. Okay, so again, we got two lengths coming from this point. From here to there is the same as there to there, is the same as there to there, is the same as there to there. And if I connect with a nice line, I create a 90-degree angle. Now, how do I make this an isosceles right triangle? Well, you can't assume this is isosceles. It's not. You could double check and it's not. But you know what you could do, my friends? You could just draw an arc. And when you draw an arc, I'll draw four different isosceles right triangles. Ready? Here is one isosceles right triangle. What are you talking about, Mr. Mester? That's not a triangle. Yes, it is. Connect this point and this point, and you've created a triangle that has a right angle whose side lengths, this one and this one, are the same. You want another one? Sure, I'll give you another one. Here, let's move this over there. Let's draw this arc. Bam, I've just created another isosceles right triangle. Like, what are you talking about, Mr. Mester? It's like right here, right there. I know that this length and this length are the same. And you can keep repeating it, It's easy. And it's just like Mr. Rhombus is helping us. How are we going to do a 15-degree angle? Well, this is tricky. I know that I can create a 60-degree angle. And from a 60-degree angle, I could split that in half and create a 30-degree angle. From a 30-degree angle, I could split that in half and create a 15-degree angle. So that's what I'm going to do. I'm going to start with a 60-degree angle. How do I create a 60-degree angle? Mr. Equilateral Triangle is going to help me. Where's Mr. Equilateral? Oh, here it is. All right, so let's use this length. Here's that length repeated, and all possibilities of that length in any direction. Here are all possibilities of that length. in any direction going this way, I can see we have that same length. Obviously, I should see the arcs there, but now I got this point there, connect with the straight line, and you have your friend the 60-degree angle. Now I need to split that in half. How am I going to do that? Well, why don't we just keep going with that same length from these points? And what have you created? Well, this intersection where this length is the same as that, which means you've created 1, 2, 3, 4 side lengths that have the same length, which means you've created a perpendicular bisector of the diameters, and you've created a angle bisector of the angles. Okay, so now I know this is 30 degrees. Once I have that it's 30 degrees, I need to create another bisector, and I actually can't. I could use that, but now we have this line that we need to kind of take care of that needs to be bisected with that line. So like we have a new angle. I need to kind of start over. So I'm just going to pick a different radius. Boom, create a new isosceles triangle. This length is the same as this length. We could connect these 2 points to create a diameter, and the diameter, and I'm sweating, not a diameter, a isosceles triangle. It is a diameter of a rhombus. And then we got this length continued up there. And then over here, that length is continued. And boom, we've created a rhombus, Mr. Construction Friend, and the rhombus connects with the vertex to create a diameter. And not only do we perpendicular bisect the diameters, but we bisect the angle. So this angle right in here is 15 degrees. I took a 60, cut it, and then I cut it again. Just a rhombus and a rhombus. All right, let's chase some angles. I did this earlier, and it's fun but tricky. So let's talk about what do we see. Here's some things that people miss that I missed the first time. That angle, that side length and that side length are the same. That means this angle and this angle are going to be the same. That's important. That length and that length are the same. That means this angle and this angle are going to be the same. That's important. This is 90 degrees. This is important. This angle and that angle are the same. What can I use? Let's add another pen. Angle A and the angle next to it is the same. So we need to use that. Orange. Let's go into the orange ones. That is a favorite. So this angle here and this angle here are the same. Okay. And that's it. We kind of just have to start figuring out. I got 72 degrees here. I got 90 degrees here. Okay. All right, I see it. Do I see it? I'm gonna extend this line here because I see something. I see that this is a copy of this. So like if this is 72, this is 72. That doesn't really help me though. But if that's 72 and that's 72, this is 72. They are alternate interior angles or vertical to the corresponding. If that's 72, that's 72. That means this is 144, which means this is 36. If that's 36, this is 36 because they're alternate interior, or you could say this is 36, and that's corresponding if you just look at this picture and copy it. Okay. Okay. Okay, if this is 72, this and this must be the same. That means doubling x's plus 72 must equal 180. Well, that means doubling x's has to equal 108. That means x is 54. So this angle here is 54. This angle here is 54. Okay. That helps me find this angle here. Oh, if this is 36, this has to be 36. If this is 90, 90 and 36 is 126. That means K has to be 180 minus 126, which is 54. Oh, what?
I do understand. Oh, look at this. This is the.
Okay. This is 36. These two angles are on a straight line. So 180 minus 36 is 144. That's 144. That's 144. If that's 144, then this plus this doubled. Double y plus 144 has to equal 180 because these two angles have to be the same. So double y has to equal 36. Y has to be 18. So this is 18 and this is 18. If this is 18, this is 162. If this is 36, this has to be 36. If this is 54, this is 180 minus 54. 180 minus 54 is 6 gives me 26. All right. I don't think on your test you're gonna have anything that crazy in terms of angle hunting. Constructions, man. If you could create an isosceles triangle on top of an isosceles triangle, you win. You can do anything. You can bisect. You can do the only things that are different is like adding side lengths, but everybody is cool with adding side lengths, hopefully. I would advise you, if you wanted extra work, is to do the big quiz review again, as well as Delta Math for extra practice. The review is due the day of the test, but turning in a review is not the same thing as being prepared for the test. The test is worth 10% of your semester grade. Turning in the review is worth 1/3%. Okay. It is so much more important to make sure you understand, you know what you're doing, than just saying, I did it. So do your review multiple times. Make sure you do your constructions multiple times. Make sure you really understand how to do your stuff. Project is due Friday for my class. So do it. All right. Good luck out there. Practice, 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 practice. 10% coming up Wednesday. Peace.